Okay. Yes. Mhm. Yes. I did post the full review sheet online last night, so the full review sheet. So I went through, recorded it, and did every single problem. The video is pretty sizable. I think it's about an hour and a half. But on some of the problems, especially the ones we did by any method, where I said you can do it any method, I think the first one, our x squared plus 3x plus 2, I think we did it by graphing, factoring, and then moved on. In the video, I did go over it again by graphing, factoring, completing the square and quadratic formula. So I did multiple of the problems in multiple different ways to show you that there are several different ways we can do it. Some of them are easier than others. But on the test, you're only needing to pick one, unless it tells you specifically, like these here, 26 and 27, to solve by the quadratic formula. So if we're using the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Here we do have to use the quadratic formula to solve these here. When solving by the quadratic formula, we do need the equation equal to 0. So for this here, the first thing we can do is add 5 to both sides, telling us negative 4x squared plus 3x plus 5 is equal to 0. Now, on these here, we saw, especially in the notes over 3/6, with using the quadratic formula, having a value, a negative number in front of the x squared term, did make things a little tricky, especially at the end. Well, not tricky, but it gave us a negative number in the denominator, which we ended up having to fix. So instead of doing that, we can just divide everything by negative 1, giving us 4x squared minus 3x minus 5 is equal to 0. Yes. Questions on what we did here? If the number in front of x squared is positive to begin with, or positive when you start trying to solve, we don't have to do this. We only have to do it if a is negative. Now this is referring back to our ax squared plus bx plus c. That's where we find a, b, and c, or how we know which one is a, b, and c. And for us here, a is, b is, and c is negative 5. When we plug it into the formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. At this point here, we just need to plug our values in. Negative b, well, that'd be negative 3. Plus or minus b squared, well, that'd be negative 3 squared. Minus 4, a is 4, c is negative 5, all over 2a, 2 times 4. Our negative 3 is going to be positive 3, plus or minus square root. The denominator, 2 times 4 is 8. Now we do need to plug everything inside the radical into the calculator to simplify. Negative 3 squared minus 4 times negative 5 is 89. Questions on how we got to this part here? We feel comfortable getting to here? Now at this point, we do need to see if the radical will simplify. I'd plug it into the 30xs, second square root, 89. is square root of 89. It doesn't reduce. If we can reduce the radical, we do need to reduce it. The graphing calculator, unfortunately, will give us the decimal approximation. We want to keep it in radical form. So here it's just the square root of 89. Because if the radical can reduce, we want to reduce it. I'm not going to make you reduce the whole fraction if the top two numbers have a common factor with the bottom to simplify that out. I want you to at least get to this here. Like earlier or yesterday where we had the square root of negative 20, we took the negative out as I, reduced the square root of 20 to 2 square root of 5. I want you to do that. I'm not going to make you reduce the whole fraction because we did talk about that yesterday. Questions on this here? Any other questions on quadratic formula? If you do have questions on 27, please let me know. Also, the full video does have 27. 28 through 30, find the value of the discriminant and describe the types of solutions. So our discriminant is our b squared minus 4ac. Now there's three setups that we can have with the value of the discriminant. It's either going to be greater than 0, equal to 0, or less than 0. That's the only three options we have. If the value of the discriminant is greater than 0, that quadratic is going to have two real solutions. If it's equal to 0, we're going to have one real solution. And if it's less than 0, we have two complex solutions. We have one of these three options here. And I would make sure that you have that written down somewhere on that page to reference back to. Because what we're going to do for these here is we're going to find the value of the discriminant and describe the types of solutions. I'm not going to ask you to find the value of the solutions on the test. Yeah, this. I'm not going to ask you to solve them and actually find the solutions. I just want to find the value of the discriminant and the type of solution. So this here. It's taking her a while to find a locker. So, if we look at the first one here, 48 or 4x squared equals 5x minus 10. Well, to be able to use this, we do need this equal to 0. So to find the value of the discriminant, we do need the quadratic equation equal to 0. So we get 0 equals negative 4x squared plus 5x minus 10. Well, normally at this point, like the last one, we would make the value of a be positive so we could go about solving. Here, are we actually solving anything? No, we're just wanting to find the value of the discriminant. So I'm just going to leave it alone. Say a is negative 4, b is 5, c is negative 10. Because even if we did make the a value positive, the value of the discriminant would stay the same. It would still be the same value. And our b squared is going to equal, so we're going to find the value, not equal. Find the value b squared minus 4ac. Our b value is 5. So we have 5 squared minus 4 times negative 4 times negative 10. And at this point here, we're going to plug the whole thing in. Grab a calculator. Parentheses 5, close parentheses squared, minus 4 times negative 4 times negative 10 is negative 135. So the value of the discriminant for this is negative 135. Is that greater than 0, equal to 0, or less than 0? So that means we have 2 complex solutions. That's it. Questions on this here? Now, I will show you this. This is not really anything additional. I'm going to get this color. If I would have divided everything by -1 to make that a value positive, well, what it would have changed was a would have been positive, b would have been negative, and c would have been positive, yes? So when we plugged it in, I would have had -5 squared, +4, +10, yes? So let's see what the value is in the calculator. Parentheses, -5 squared -4 times 4 times 10 is still the exact same thing. So that doesn't change that value. It just makes it easier to solve because now we don't have -a in the bottom. The bottom of the fraction is not negative, and we can go from there. Questions on this here? Do we want to look at 29 or 30? We're good with these here? Yeah. Yes. 29? So again, with 29, we need to make it equal to 0. So what can we do first? Yeah, subtract x from both sides, which would give us -2x squared minus x minus 6 is equal to 0. The value of a is value b, value of c. Now that we have those three values, we need to find the value of b squared minus 4ac. So we'd have -1 squared minus 4 times a times c. I'm going to plug it into the calculator. -1 squared minus 4 times -2 times, what was it, -6? -47. Less than 0, so we have 2 complex. Yeah. If it's greater than 0, we have 2 real solutions. If it's equal to 0, we have 1 real solution. On the test, because these will show up on the test, I think they're worth 4 points. I know I award, or if you get the -47 correct, I believe that is worth 1 point. If you get the number of solutions, the fact that for this one there are 2, I do give you a point for that. And if you give me the correct type of solution, complex, I do give you a point for that. So you get a point for each one of those. I have had some students that gave me the wrong number. Yes? Yes. Put down, instead of -47, they gave me, I think it was like 200. They gave me a positive number, put 2 complex solutions anyways. I mean, technically, they still got the 2 complex solutions right. They just got the wrong number. Don't know how they put those together, but I still gave them the points for everything except for having the wrong value. Questions on this here? 31 through 33, create a perfect square trinomial by finding the value of c and factor it. Well, c is equal to what? Squared. b over 2 squared. So 31. Go this far. C is equal to b over 2 squared. And for 31, our value of b is what? -24. And again, at this point here, I would plug it in first, or I would divide first. -24 divided by 2 is what? Negative 12. And negative 12 squared is 144. So we're saying x squared minus 24x plus 144 is our perfect square trinomial. And when we factor, we want to set a parentheses squared and our x minus 12. The number that goes inside the parentheses with x is whatever we have inside the parentheses before we square it to find c. And it works out that way every single time. And that's it. Questions on this here? Let's look at 32. C is still equal to b over 2 squared. For 32, what's our value of b? 29, and it is positive. 29 divided by 2 is what? 14.5. If it turns into a decimal, leave it as fraction. And 29 over 2, if it doesn't reduce, it's just going to stay that. Because 2 would simplify out completely. It's either going to be there or it's not. So we're going to leave it alone. Now we just need to square it. Let the calculator square it for you. 29 over 2 squared is 841 over 4. So our perfect square trinomial is this here. X squared plus 29x plus 841 over 4. Now we do need to factor this to a set of parentheses squared. And it seems like with having as weird a number as that is, it would make things harder, but the number that goes inside the parentheses is whatever we had inside our parentheses before we squared it to find c, which is plus 29 over 2. Since it's positive, it would be plus. And that's it. Questions on these here? I'm going to do one more. I mean, they're not bad. Didn't take much time. Let's go with this shade of purple. C is equal to b over 2 squared. Our b value is 49. Well, 49 divided by 2. It does, but we get a decimal. So we'll leave it as a fraction. And we'll tell the calculator to square it. 2,401 over 4. 2401 over 4. So we get x squared plus 49x plus 2401 over 4. And we put the number and sign of what we had inside the parentheses in finding c before we squared it in there, and that's it. Questions on 33? Are you ready for the last part? Or the last, well, main section, which is all dealing with I. Yes. Unless you talk to me and we work something else out. Now I, powers of I to any power. We take whatever that power is and divide it by 4. If the decimal is 0.25, it reduces to I. If the decimal is 0.50, it reduces to -1. If the decimal is 0.75, it reduces to -I. If the decimal is 0.00, and most calculators don't put a decimal, if it is 00, it reduces to 1. So the first one, I'm just going to look at this one here, 2,874. I'm going to divide it by 4. 2,874 divided by 4 is 718.5. I'm not concerned with the 718. The main thing I'm focused on is the 0.5. What does the 0.5 connect to? -1. So what it's telling us is I to the 2,874 is -1. So E, I to the 6,971, we take that power divided by 4. 6,971, yes. Divided by 4 is 1,742.75. Because the only one we're worried about is the 0.75, which tells me that this is -I. That's it. Because we're just looking at the decimal. So if we looked at, say, A, 27 over 4, calculator, 27 divided by 4 is 6.75. Not worried about the 6. I'm looking at the decimal. 0.75 is -I. Yeah, so it doesn't, the number itself is just telling us how many cycles through those 4 we went through. Because the 718, that means I have I being 718 times. When we multiply that by itself 718 times, we still get 1. 1 times, well, our 0.5 tells us it's -1. It's just -1. So we're not focused on the whole number, we're just focused on the decimal. Questions on these here? We ready for the next set? Evaluate each expression. I do go through this, at least one of addition, one of subtraction, one of multiplication by hand on the full lesson video. If you want to go and watch those, you can. Don't have to. But if we look at this first one here, I'm going to grab the graphing calculator and type it in exactly as it shows. 6 minus 7i plus 4 minus 3 second I. Enter. Is 10 minus 10i. And that's it. If we look at B, 7i minus 27 plus 3i minus 2. Enter. Is -29 plus 10i. That's it. For A through E, I mean, we can look at E. 189i minus 361 second I squared, well, not plus, times plus 71 I squared minus 38 I to the 4th is here. I mean, we have the same thing with subtraction. 74 minus 6i minus 27 minus 3i is, it'll do it for us. Questions on addition or subtraction? Let's turn the page. The next 6 that we have are multiplication. Calculator will do it for us. We just got to plug it in. Doesn't matter how many terms we got. It'll do it for us. Questions on? Graphing calculator can do powers of I, but I would stick to the dividing by 4 because if we get too big of power, it starts throwing in a pixel error as it's trying to calculate it. So then we have to decipher it. It's a little bit easier, just divide by 4, look at the decimal, and go from there. Any other questions on addition, subtraction, or multiplication? Division, we have to type it in a little bit differently because the 84 plus does not let us use alpha y equals enter. Fortunately, we need the CE for those to be able to do that. And you all have any guess at what CE stands for? Color addition. That really is what CE stands for. Because y equals, it has different colors. It will graph in color. It has a few other features. One of them is that we can actually put I in fractional form in top and bottom. Now, to do this, what we have to do for this here, so scroll down to L. What we have to type in is this, 8 minus 4i divided by 3 minus I. The numerator in parentheses divided by the denominator in parentheses. And once you get that calculated, math, enter, enter. Once you get that calculated, math, enter, enter. Your calculator, you won't have to do that last step because you can put it in fractional form already, and you don't have to convert it out of decimal. So, in the calculator, what we would do is 8 minus 4i divided by 3 minus I. Once we type it in and hit enter, we get this here. Now, since it is in decimal form, we have to hit math, enter, enter. We hit math, and the first one in the list is to turn it into a fraction. We hit enter to select it. We hit enter one more time to tell it to go on and turn it into fractional form. And we get this here. Questions on this here so far? So we can look at M. And we get this here. Now for this one here, we don't necessarily need to put the 4 in parentheses because it's one term, but it's better to put it in parentheses than not. Questions on L or M? Questions on NOP? Nope. Fine. Questions on NOP? Nope. Yep. So we feel good with addition, subtraction, multiplication, division. Now the last one that we have, I realize I still need to update this review sheet, is that I've forgotten to put QRST on this. Q. So for these last few, find the complex conjugate and their product. So what's the complex conjugate to 4 minus 3i?
I was doing my homework, and I knew how to do this, but I didn't know how to get the product.
So what's product?
So like,
Well, the product of two things is what operation? Addition, subtraction, multiplication, or division? Anybody know? Multiplication. So product, their product. Multiply them together. 4 minus 3i times 4 plus 3i. And again, we could do this by hand, or we can tell the calculator. Tell me what 4 plus 3i times 4 minus 3i is. And it is 25. So our two answers for Q are 4 plus 3i and 25. Yeah, because if it's asking for their product, we're multiplying them together. And the reason that it's interesting is that every time we multiply a complex number and its conjugate together, it will always be a number. It'll always be a number.
I was doing some of my homework yesterday, and I was like, it was equal, and I was like, so I was gonna ask it.
18 plus 14i. And to find their product, 18 plus 14i times 18 minus 14i is 520. 18 minus 14i and 520. That's it. Any other questions on S or T? S, we have 8i. Its complex conjugate would be? And its product would be? Which I believe is 64. Well, 8 times negative 8 is negative 64, or I times I is I squared, but I squared is negative 1. So negative 64 times negative 1 is 64. And that is the whole review sheet. I would make sure if you need the factor or the steps for factoring, I would write those down probably in the section with factoring. I also did include the a squared minus b squared, our difference of perfect square formula. So if you want it down, I would write it. For completing the square, I would write the ones that we have to do completing the square by, the steps for it down. Greatest common factor. I would write the powers of I set up down for when we're trying to find the powers of I. I would make sure the quadratic formula is down in the section for quadratic formula. We have this here. If you do have trouble remembering the steps to go through for graphing, I would write those down because there are 4 that require you to graph to solve by graphing. 4 that are requiring in part 1 that are going to require you to solve by factoring. At least one of them is already going to be factored. You just have to take it from there. 2 sets of parentheses equals 0. One of them must be 0. Solving by factoring, factor it, and then set each set of parentheses equal to 0 and solve. 2 by quadratic formula, 2 by completing the square. And that's there. Now, part 2. Everything that's going to be on part 2 is our powers of I. Addition, subtraction, multiplication, division of I. Our complex conjugates and their product, and discriminant. Those sections are all a part of part 2. Anything else on the review sheet will be part of part 1. I did have someone ask me earlier about the breakdown of the points. Actually, I don't know. I think I just volunteered this information, but I know most of the tests that y'all know are worth 100 points, and then I double it to put it in the grade book. This test is actually worth 200 points. Half of it is part 1, half of it is part 2. So hopefully that is good news for y'all, because that means half of it is powers of I, addition, subtraction, multiplication, division with I, complex conjugate and their product, and the discriminant is half the test. So worth 100 points just for that half. If you do have any other questions, please let me know, email me. We can work, I can talk with you, help you out. If there are some that you come across or just want to see worked again, the full review sheet is online. You do not have to watch the whole thing. If there's specific ones that you're needing help with, go to those, watch those. But that's it.